Okay, this is the continuation of our 8-2 video. This is the last 5 questions, which are your story problems. The first question says the cost of a pizza is $8.50 plus $1.35 per topping. How many toppings are on a pizza that costs $13.90? So the first thing we have to do in all of these, and I gave it to you beforehand, is defining the variable. And usually, if you look at your last sentence, the question sentence, it says how many toppings are on a pizza. So 99.9%, usually the variable will be what you're looking for. So in this case, it's how many toppings. So the first thing you're going to do is you're going to define the variable. So I'm going to put down x is going to represent what it's representing, how many toppings they have, or the number of toppings. So if it's $1.35 per topping, that means I'm going to take the toppings and I'm going to multiply however many I get by $1.35. That becomes a coefficient and a variable, okay? So $1.35 is now your new coefficient for x because you're multiplying however many toppings you buy by $1.35, and that's what a coefficient does. And to that, you still have to buy the pizza, which is $8.50. So that's going to act as our constants, because regardless of how many toppings you buy, the cost of the pizza is going to be $8.50. So if you buy 0 toppings, your pizza is going to be $8.50. If you buy 1 topping, it's going to be $10.35, etc. But we know that whoever bought this pizza, the total cost before tax came to $13.90. So algebraically, that is an equation that represents how I'm going to solve to figure out how many toppings were purchased. So the first thing I'm going to do is going to remove the cost of the pizza itself by subtracting $8.50 from both sides. That's going to leave me with however many toppings I actually bought. And that's going to be $1.50 plus $3.90 is $4.95.40. Now that we have that, divide both sides by the cost of a topping, and you will isolate for x, telling you that x equals 4. Okay? So therefore, put your therefore symbol. Now you redefine it. The number of toppings on the pizza was 4. Okay? So again, just to reiterate, first thing we did, we defined our variable. Second thing we did, we created an equation. Third thing we did is we isolated the variable to figure out that x was 4. And the last thing we did is we defined our answer with a sentence. That is the procedure for all story problems. You get it? Question 14. Spelled correctly, Zdanovich paid $34.95 to rent a car for a day plus 12 cents per kilometer that he drove. The total rental cost before taxes was $55.11. Now here we go. There is your sentence. How far did he drive? So step 1, x equals number of kilometers he drove. And I get that simply from the last sentence, the question. How far did he drive? So we're going to make x represent how many kilometers he used, or how far he drove. So if we go back into my equation, it's 12 cents for every kilometer he drove. And if x represents how many kilometers he drove, then each of those kilometers is going to be multiplied by 12 cents. So the expression 0.12x is going to be the cost per kilometer multiplied by however many kilometers he drove. Plus, the constant here, regardless of how many kilometers he drove, the constant here is going to be $34.95. Because no matter how many kilometers he drove, he still has to rent the car for $34.95. So, his mileage plus the cost of the car, we know, cost him $55.11. So there's our equation that we can create to solve for how many kilometers he drove. First thing we're going to do is subtract the cost of the car, the rental fee, and the 12 cents per kilometer is going to equal Murphy's Law says wherever I'm writing, the calculator will cover it. 55.11 take away 34.95 is $20.16. So that's the cost that was added on for his mileage. So if we divide that by 0.12, or the cost of 12 cents per kilometer, X will equal, is it that much? Wow, 168. Okay, so now that we've solved it, we go back into our original part. X equals the number of kilometers you drove. X, therefore, he drove 168 kilometers. Do you have your license, Danovich? Do you have your license yet? Okay. Your father then. Question 15 says, on Saturday morning, Carol had a quarter of her weekly allowance left. She spent a total of $6.50 on Saturday afternoon on paper and pencils to draw cats while in math class. After spending that, she had $2.25 left. How much is her weekly allowance? So going back to what we said before, step one. There's our question. And find the variable from that. So X equals her weekly allowance. Step one. Step two is try to create an equation. So if she had a quarter of her weekly allowance left, a quarter of her weekly allowance left, algebraically, that's taking her weekly allowance, and you can either represent it fractionally, a quarter, or a quarter of her weekly allowance. So 0.25, meaning a quarter of her allowance, or you could also do it this way over here, a quarter of her allowance. Now, given that this is a decimal, and I have to make a choice right now for how I want to algebraically express a quarter of her allowance, since the constant, I believe, is going to be a decimal, I am going to keep this expression as 0.25. So she had a quarter of her allowance left, and she spent $6.50 of it. So if she had a quarter of her allowance left, and she spent $6.50 of it, we're going to take away from that quarter of her allowance $6.50. And after she did that, she had $2.25 left. Okay? So the equation we need to use to solve is going to be this one. So we're going to give her back the $6.50 she spent on paper to draw, pencils and paper to draw cats. We're going to give her back that. And the quarter of allowance that she had before she bought the paper and pencils would have been $8.75. So if she had a quarter of her allowance left and it was $8.75, if I divide both sides by a quarter, then that means the amount of allowance she should have had left is $8.75 divided by a quarter. And most people think that's going to be smaller than $8.75, but it's not. It's going to actually be multiplying it by 4. The answer is 35. And remember, if I think about $8.75 divided by a quarter, if I think of that fractionally, 8 3/4 divided by a quarter, right? If I think of that same question here, fractionally, I know that I would solve it by keeping the first fraction and changing to multiplication of the reciprocal. So when I divide by a quarter, it's the same effect as multiplying by 4, right? That's why it made it bigger. And therefore, she gets $35 a week as an allowance. That's pretty good. Yeah, $35 a week. Was it a week or a month? Weekly allowance. She comes from very affluent parents. Yeah. And finally, question 16 says, Izzo has a summer job in an electronics store. She is paid $400 per week, which in itself is pretty darn good. Plus, she gets 5% commission on the total value of her sales. Now, one week when the store wasn't busy, Izzy only earned $510.30. What was her total values of sales that week? So, Starting with the first thing we need to do, what was the total value of her sales? Define the variable. X will equal the total value of her sales. Okay, first one. So a 5% commission on the total value of her sales is what she gets as an extra. Okay, so I'm going to start with this one first. So she gets $400 regardless of how much she sells. Plus, she gets a commission of 5% for the value of her sales. So 5% of her total sales will be 5% of means multiplication of X, or since of means multiplication, 5% of her total sales will be represented by the expression 0.05X. Does that make sense? Perfect. So, what she gets regardless of what she sells, plus 5% of her total sales represents her total check that she's going to get for the week, which in this case was $510.30. So the first thing I'm going to do is subtract her weekly salary of $400 to realize that her commission for that week must have been $110.30. And 5% of what number? If I divide by 0.05 and divide by 0.05, that means that the amount of money the amount of product she sold would have been 110.30 divided by 0.05. That means she sold, therefore, Izzo sold $2,206 that week. Is that the last question, or is there one more? One more. And your last question. The temperature in Lower Wellington. If you've ever been to Wellington, it's a very large metropolitan area. They used to have a pizza place. I don't know if they have one anymore. The temperature in Lower Wellington was 7 degrees and was falling by 2.5 degrees per hour. How many hours did it take for the temperature to reach? So, how many hours? So X is going to be the number of hours. So here we started with 7 degrees. And from that 7-degree temperature, we're going to take away 2.5 degrees per hour. So if we think about this, so if X equals the number of hours, then if I multiply that by negative 2.5, in 1 hour, that would mean it would drop 2.5. In 2 hours, it would mean it would drop 5. So I'm going to treat that as negative 2.5x. And at the end of this whole dropping period, the temperature finished at negative 5.5. So it started at 7, and it dropped 2.5 degrees multiplied by the number of hours. So what I'm going to do is I'm going to subtract 7 from both sides because 7 is my constant. So by subtracting 7 from both sides, I end up with negative 2.5x is equal to negative 12.5. And finally, when I divide both sides by negative 2.5, I'm going to isolate the variable x, and that's going to equal 5. So therefore, it took 5 hours.